All right, welcome everybody to the Tuleyome Nature and You lecture series for July. So we're going to start out by me giving a little spiel about Tuleyome before I introduce Glen. So Tuleyome, we are a nonprofit based in Woodland, and our focus is the northern inner coastal range of mountains. So the Berryessa Snow Mountain National Monument area, and we also work in the Woodland area at the Woodland Regional Park. What we want is for people to get out and enjoy nature. So go out for hikes, go out on wildflower tours, help us with building some trails. Tuleyome does guided hikes. We have a lot of information on our website. If you're watching this on YouTube, look down in the information and you can see our link. There's also a link to future events. Next month, our lecture series has a lecture about wood ducks. So that should be really fun. Wood ducks are neat birds. We're going to keep everybody on mute during the lecture and video off. It helps with the bandwidth. And then if you have questions, you could ask them in the chat, and you could just keep typing in the chat throughout the lecture, and then we'll get to the questions at the end. And if it works out, we get through all the questions in the chat, we'll see if we can open it up to everybody, and you can turn your video and audio on, and we can just have a regular discussion. That should be fun. Our guest speaker today, Glen Holstein. Dr. Holstein received his PhD in botany from UC Davis and is retired from his position as senior scientist with Zettner and Zettner. He is also a Tuleyome board member and has been for many, many years. So he's one of our superstars at Tuleyome. He leads our wildflower tours. He's a guest lecturer for our Certified California Naturalist class. So without further ado, take it away, Glen. Thanks for coming.
Thank you, Bill. Nice to see all you folks. So the talk tonight's about California's biodiversity. Biodiversity is the number of species, or in some cases, other genetic groups. And so that number is very significant. When we talk about hotspots of biodiversity, we're talking about places that have lots of species in a limited area. Mm-hmm. So this is not just theoretical. It actually has numbers associated with it. And California is first among states in overall biodiversity and overall endemics. And we're going to explain what endemics are next, but we're also number one in plant biodiversity and endemics, vertebrate animal endemics, not total biodiversity of vertebrate animals, but endemic vertebrate animals. We're number one in mammal biodiversity and endemics, and we're number one in, this is among other states, of freshwater fish and amphibian endemics. Even though we don't have as many species, we have more species that are only found in California. These are the endemics. Endemics are species limited to an area. Some are old and some are new. This concept that they're old and new endemics actually originated at UC Davis with Stebbins and Major with regard to botany. But as we now can read genetics, read genes, see real relationships, which is especially moving forward with perching birds, we can see that even though some of their assumptions, which were based on morphology, weren't necessarily backed up, a lot of them were. And we can get a lot of ideas of what's a new endemic and what's an old endemic. Kangaroo rats, for example, are a group with lots of species right here in California. Southern California especially is a hot spot for biodiversity of these little animals. And this suggests that they've done a lot of relatively recent speciation in a limited area. And we have lots of species in the small area of California. Same way with chipmunks. Chipmunks are more diverse in California than any place in the world. Really, California is the world center for chipmunk biodiversity, and they've spread pretty much into all habitats except for some very extreme habitats here in California. This one's a little darker than most of the chipmunks you see. This is the yellow-cheeked chipmunk that's only found in the wettest and foggiest parts along the northwest coast of California, north of San Francisco. And a lot of the other chipmunks have very narrow ranges in a particular habitat. That's why we have so many. This is an example of a new endemic that has spread out to many different habitats, probably relatively recently. Now, an example of an old endemic is our pronghorn. Now, they're in California, but they're endemic to North America, not just endemic to California, but they're an old endemic because they don't really have any other relatives except in the fossil record. They're the only species left in their family. And for a long time, we didn't have very many in California, but we're starting to help them come back to California where they once were, and they're doing very well here. So it's a real pleasure to see those when we get a chance to. An old endemic plant is the California Rhododendron. It doesn't have any near relatives in California, although there are a couple of other rhododendron species that are not very close to it. And it's found in a kind of an isolated place that has unusually good conditions along the northwest coast of California, where it's very cool and very wet, and it's not exposed to the droughts and extreme temperatures we get in most of the rest of California sometimes. But we also have a lot of groups that have really exploded and produced lots of species, including many endemics in California. One of the genera is the genus Castanea, which in shrubby areas produces these bright red flowers, many species, and they're referred to as paintbrushes. And in open areas, we have what are called Alice clovers, but they're considered closely related enough to be in the same genus Castanea. And once again, many, many species here in California in our open areas. A family called Themidaceae is particularly well developed here in California. They used to be kind of lumped in for the most part in Brodia, but now they're separated into several other genera. But we have many species in most parts of California, and many of them, like this ethereal spear, are extremely beautiful, and they add a lot to the beauty of California. We also have a lot of onions. Now, onions look like they might be in the Themidaceae, but they're in a completely different family. Many, many species, lots of endemic species of onions in California, but they tend not to be very abundant. So you'll see a few here and there. This particular one, Allium cratericola, is associated with serpentine, which is up on Walker Ridge, an area that we've been very interested in conserving here at Tuleyome. An important family for diversity that has many, many endemic species in California is the Polymonie Acid. A good number of them are annuals, and some of them are very tiny annuals that will only appear just for a few weeks at just the right time. And as a result, unless the botanist is there in the local area where they appear, they might not ever be seen. And as a result, a lot of the new species that are being discovered every year are in this family, the Polymonie Acid. They're oftentimes found at the edge of deserts, but this particular one is widespread in the North Coast Range. Lupins are another big group. Most of them are blue like this, with many, many species, including lots of endemics here in California. but we also have some with other colors as well. One of the most beautiful genera that has really exploded with lots of very, very different species all over California is Clarkia. And this particular one's covering this hillside with bright pink. Many other colors are found. It's got some other genera in the same family, the evening primrose family. Very, very important for this explosive new speciation that we're seeing to cover California's landscape. Sidalcia is in the same family as hibiscus, and we have a number of species in that genus, including some that are perennials in forested areas, and we have some in vernal pools, but this particular one is in open areas and just covers landscapes with its beautiful pink blossoms. One of the most important sources of new species here in California are the Mariposa Lilies that are widespread in a very great variety of habitats here in California. This is golden nuggets. It's common in the North Coast Range, but we have many others all through California. Even out in the deserts, there are species in this group. So if we look at North America, we can see that our little state of California that has so much endemism and diversity is really cut off from the rest of North America. As the rain comes in from the west on the westerlies, it reaches California, it reaches Oregon and Washington, and then all these ranges of mountains pretty much stop it. So that unlike Europe, where the westerlies can carry rain all the way from the Atlantic Ocean all the way into Russia to Moscow, the westerlies pretty much have to stop. There's a few breaks, so we get some forest in here. We get forest where in the Sierra Nevada where the westerlies stop, but most of the water gets pulled out by all these mountain ranges. So further east, we get water coming up, very warm water and very warm moist air coming up from the Gulf of Mexico into the central part of the United States. And then we get cold Arctic air coming down from the north. And when these meet, it's really the only place on Earth where these two very different air masses can meet so dramatically. We have the world's most powerful tornadoes here as a result of this meeting of very cold air and very warm air, very moist air. And that provides plenty of water for the East Coast. And also, as warm ocean water moves north, it is, because of the Coriolis effect, caused to spin more and more. So we get tropical storms and even hurricanes very well developed here because we're a long way from the equator and we have lots of warm water here. But we don't get it much in California because we have a cold current that comes down from the north. So our water is chilled and doesn't produce the warm, moist air that tends to produce hurricanes. Once in a while, we get hurricanes down here off the Mexican coast that sometimes can come up and reach our deserts, but that's a pretty rare phenomenon. One thing to notice here is that all this moist air that produces lots of the moisture in the eastern part of North America only comes up this far east. It doesn't come up from here because this is land. And as a consequence, moisture drops off and we get short grass, dry prairies here in a band just east of the Rocky Mountains. Now we see the same kind of pattern in detail here in California. We get Sierra Nevada mountains. Further north, we get Cascade Mountains, which consist of a few volcanoes like Mount Lassen and Shasta, with Modoc Island in between, covered with forest for the most part. And that forest then extends because as you go south in the Sierra Nevada, they get higher, so they stop more rain. So the moisture continues well down into the highest parts of the Sierra Nevada. And then it also hits these Sky Island mountains of Southern California, like the San Emigdio Mountains, San Gabriel Mountains, San Bernardino Mountains, and then you get the Peninsular Range as well. Now there's less moisture coming in with the westerlies the further south you go, but there is some, and it decreases as you go north. Up in the far north, we get the Klamath Mountains, which are in direct line with the westerlies, so they're very moist and low enough, even though they're fairly low, they still get lots of snow and even some ice. And then we have the Coast Range, the North Coast Range and the South Coast Range. And the westerlies don't come in straight from the west. They come in from the southwest. So that areas that are exposed to the southwest, like for example, Santa Lucia Mountains are exposed. They get a lot more rain than anywhere around there. We get the same phenomenon around Mount Tam in Marin County. We get that in the upper North Coast Range. But another factor that brings moisture in addition to rain is fog. So these areas that stand out into the
Turn down more still here.
I'm sorry to interrupt. Whoever's got their sound on, can you turn it down? Turn it off, mute, please. Somebody named Ann Grench. Great, thank you. Go ahead, Glenn.
Okay. So areas like this peninsula south of Eureka, the area around Fort Bragg, Point Reyes, Point Pinos, Point Concepcion, they tend to extend out into the cold current. So those are areas that get the most extensive fog. Of course, fog brings moisture, and it also and for example, at Point Pinos here, it's not in a position where it gets a tremendous amount of rain because it's relatively low, but it's very foggy. Whereas the Santa Lucia, the mountains here in the Santa Cruz Mountains, because they're exposed to rain coming in from the southwest, are very much an area of high rainfall. So for example, Santa Cruz is warm and sunny because it's protected from fog, and yet it has high rainfall, whereas Monterey has less rainfall, but it's very foggy. So we have different effects on vegetation. Above Santa Cruz, we have an island of redwood forest, another island of redwood forest down in the Santa Lucia Mountains south of Monterey. But Monterey has plants that are associated with fog, like Monterey pines. Similarly, you get bishop pines up here in the north. You get bishop pines down by Point Concepcion. And then the fog belt extends to the outside of the Channel Islands. So we have an area of very little fog and warm water all around from Santa Barbara down to San Diego. And then the fog belt reappears around Ensenada, and those pines that are associated with the fog belt reappear around Ensenada after a break from Point Concepcion clear down to Ensenada. We also get some of them on the Channel Islands. And the Channel Islands are real centers of endemism because they're separated from the mainland of California. They've got an endemic species of fox there. They've got endemic trees. The Catalina ironwood, for example, is a beautiful tree, completely unrelated to anything on the mainland, although there are fossils of it on the mainland. There's a scrub jay that sometimes is placed in its own species that's found on these islands, and many, many species of plants here that don't occur on the mainland. Lots of island endemics. And there's even a tree that is related to our evergreen wild cherries, and it's mostly a shrub on the mainland. And this subspecies on the island is a good sized tree. So the island's very important for California endemism. Well, originally, the coast 50 million years ago of California was right here at the base of what's now the Sierra Nevadas, which had not risen at that point. So this was the coast. But as a result of plate tectonics, land masses and oceanic plates were pushed in to California, and they created two things. They created a big downdrop that is one of the largest valleys anywhere in the world surrounded by mountains. That's our Central Valley. And as it was pushed down, it filled up with sediments. And the Coast Range here was built very rapidly as a result of that collision. And this affects the climate, as we talked about with the fog and the rainfall. It also, because there's a gap here, moisture and cool air can come in, and even rainfall, so that we get sometimes fairly cool temperatures here around Sacramento, and then it gets hotter as you go north up to Redding. This is the only place I know of anywhere, at least in the United States, where without a change in elevation, you actually get higher temperatures as you go north. And because the rain also comes in, the northern Sierra Nevada, the Cascade Range, and the area just south of Mount Shasta get an unusual amount of rain. And for example, right here at Shasta Lake, the summer temperature is at least as hot as it is in Sacramento, if not hotter, and yet they get 70 inches of rainfall, something unique in California, an area where it's hot and also very rainy. And as a result, you've got an ecological island there that has one of these ancient endemics, the Shasta snow wreath, and it was found that its nearest relative is in Alabama, another place where it's very hot and wet.
You ready?
Mm-hmm. So here's our Coast Range, Snow Mountain here, the one, the northern part of our Berryessa Snow Mountain National Monument, a new range that was created as a result of that collision. And the ocean beds that used to reach the foothills of the Sierra Nevada were turned on edge. And you can see these were layers of the what was then the continental shelf that were pushed up vertically to create that northern Coast Range mountain. If you look at the vegetation of the United States, in the east, where there's continuous rain, continuous moisture, you get forest. Go further west, you get grassland, where the rain tends to be a little less, drop off, although there are some areas of prairie here associated with particular soils fairly far east, and it's complex down here in Texas. But basically, you have forest, and then you have grassland. You have patches of forest in the highest parts, like the Rocky Mountains and the Wasatch Range, and mountains up here in Montana, extending down to Yellowstone. And then all the way down from Washington down through the Coast Range and through the Sierra Nevada, down to the Sky Islands down here in Southern California, you have forest. But here in California, things are pretty complex. This purple area is the former delta. And the delta formed when at one time the coast of California, about 20 million years ago, was clear out where the Farallon Islands are. When the glaciers melted, the ocean rose because of an increase in water. It flooded San Francisco Bay and even moved inland. And it formed a saltwater or brackish water dam at the Montezuma Hills, so that water that was flowing from the southern and northern part of the Central Valley backed up behind this to create a delta, which was a very important part of the historical ecology of California, even though most of it's active farmland now. And then east of the mountains is this huge area of desert that extends all the way up to eastern Washington because of the rain being stopped by the Cascade Mountains, all through the Great Basin, Arizona, and even down into Texas. Well, things are pretty complex here in California. California is not as simple as even the entire United States. We've got desert down here in the southeast. This kind of turquoise blue is Chaparral, but we've got patches, and then quite a bit in the North Coast Range. This dark green is our Oak Woodland, although it's not quite as simple as this. It's kind of a simplification. The little bit of desert here in the southern San Joaquin Valley, the old marshes, including the marshes in the Delta. The brown here is what I like to call prairie. Oftentimes it's called grassland, surrounding the edges of the Central Valley. This red is mixed forest. It includes redwoods, oaks, and bay laurels. And then coniferous forest is in the green, the outer Coast Range, the Central Coast Range, the Klamath Mountains, the Sierra Nevada, and then patches here in the Sky Islands down in Southern California. If you look at the climate in New York, this is what's called a climate diagram. And it shows here the temperature. It's a little bit freezing in New York City in the winter, but most of the time it rises up to a maximum warmth. This is where you'd expect plants to grow the fastest because it's the warmest and sunniest. The days are longest here. And all through the season, from snow in the winter to rain in the summer, there's always plenty of moisture in a normal year for the plant communities around New York City. And these are deciduous forests. And as we saw in the vegetation diagram for the eastern United States, they pretty much extend through much of the eastern United States. Then further west, you get a similar kind of growing season pattern where it's cold in the winter, warm in the summertime, but you don't have the extensive winter precipitation. It gets a little drier in the winter, but the rainfall in the summer, when that moist air moves up from the Gulf, is enough to provide plenty of water for the native vegetation in the growing season, right there at the middle of summer and the longest days of June, July, and August. And further east, where the rain is higher, like around Omaha, you get tall grass prairie, which has become pretty rare, but there's still patches of that left. And then further west, as you get close to the Rocky Mountains, the rain diminishes pretty rapidly, and you get different kinds of grasses. You get short grass prairie and a completely different group of species with a lot less rainfall, but you still get the rainfall at the maximum in the growing season. So things are pretty green in the middle of summer. It's the best time of the year to see the maximum diversity in that kind of landscape. Mediterranean climates, though, are really different. And they tend to be in the same kinds of places all around the world. You're in California, southwest coast of North America, South America, southwest coast of South America, Africa, southwest coast here at the Western Cape, southwest coast of Europe, and the southwest coast of Australia. And that has to do with the way water moves in the ocean. These are areas where cool currents reach the coast. Each one of these is a hotspot of biodiversity. We're in one here in California. The Mediterranean Basin's one. Each one is a hotspot. But the greatest hotspot of all, and one of the greatest hotspots in the world, is this tiny little one down around Cape Town in South Africa. Tiny little area, but the number of species of not only plants, but also animals in a tiny area is just incredible. It's the kind of diversity that ordinarily everywhere else you get in even a few places in the tropics. The equivalent diversity in Africa is around Uganda. Equivalent diversity for us, you have to go down into Central America. And why this Mediterranean climate is so different is, here's that temperature range, but right here in June, July, and August, which is the time plants want to grow, we've got a drought here with no water. The water forms from rainfall, a little bit of fog in the wintertime, plenty of rain there on a normal year, although this year, this would only be up about this much. So we get the rain when it's cold and plants are not growing very much, and no rain here where plants want to grow when it's nice and warm and sunny. So this area between the rainfall and the warmth is really critical in these Mediterranean climates, which makes them so different. That means this water has to be stored someplace from when it rains to when it's actually needed, when plants are exposed to the warm air and long days when they grow the fastest. That's why the places this water is stored, soils and geology in between the winter season and the summer season is particularly important in Mediterranean climates. And because soil and geology can vary very greatly from place to place, it's one of the reasons these Mediterranean climate zones are such hotspots of biodiversity. So for example, you have this area along Cache Creek in the Berryessa Snow Mountain National Monument. You get oak trees, green grass, manzanita on the south side of or the north side of the creek. On the south side of the creek, something very different. You get gray pines, you get leather oaks, almost everything is different. And yet the climate's exactly the same. How come things can be so different? Well, the geology is very different on these two slopes. The south slope is an area where serpentine has been pushed up, which is part of the Earth's mantle in that collision I mentioned that created the North Coast Range. The area here was where the seabeds were pushed up to create a completely different chemical environment. So the vegetation here, because the geology and soils are different, the plant life is completely different. And you get similar phenomena all over California. This is the Pygmy Forest, where in one particular kind of soil, all the conifer trees are dwarfed. They only get about 10, 15 feet high when they're mature. And you get just a few hundred yards away, and you have some of the biggest and tallest trees in the world. So a huge difference here in the Pygmy Forest between where the Pygmy Forest is and where the tall coniferous forests are just outside the Pygmy Forest. This is one kind of soil. The big tall trees are on a completely different kind of soil. And that's, once again, helped by the Mediterranean climate that we have, which actually extends well north of California into even Oregon and Washington. Well, things are not always as dramatic as the difference between serpentine and non-serpentine. These are just some hills between Woodland and San Francisco. But if you notice, these hills are pretty different. This was taken at the same moment in time in May. And yet look at the non-native grasses here, bright green, fully grown in May. And the only trees are down in the deepest ravines. Whereas over here, the grass is brown, it's gone to seed, and there are oak trees all over the place. So what's so different about these two places? This is a volcanic formation here, part of the Sonoma Volcanics, that has deep cracks in it that allows that rainfall to not stay at the surface so much, but to penetrate deeply down to the roots of the oak trees to allow them to flourish in May. And by that time, the upper soil where the annuals are has dried out and they've turned brown. Over here on the Eocene sedimentary formation, which is made up of clay, clay keeps the moisture close to the surface where it allows the grass to still stay green and the other plants to still stay green that are there, a few natives. But it doesn't allow moisture and air in the same kind of quantities to get down deep, so that only where erosion has created gaps in these ravines is there enough deep moisture for trees. The hills here are completely barren. And you get that same kind of phenomenon all over California. This is in the Berries of Snow Mountain National Monument. Over here, you get gray pines and oaks on one kind of soil. Over here, a soil with a little bit more clay. You get a variety of herbs, including California poppy. A little more clay here, a little less clay here, makes a huge difference. And it's what makes California so diverse and its scenery so beautiful. Well, one of those important plant communities in California was the chaparral. This is chaparral in the Sierra foothills. You'll recognize Manzanita viscida there. Well, Manzanita is one of those young products that produces lots of endemics. Many species. There's Manzanita all through the Northern Hemisphere, but the Manzanita here in California is very diverse. Many Manzanita species. This one's pretty widespread, but you got a lot of Manzanita species that are very localized, especially in the Coast Range. So a lot of diversity and a lot of localized new endemics in Manzanita. Not so diverse is chamise, another important plant in California chaparral. Well, chaparral is extremely well adapted to burning, but not as often as a lot of people think. The plants that come out when chamise burns at its ideal time are in plants that have seeds with a normal lifetime of about 90 years. So about a 90-year gap in fires, chaparral fires, seems to be about the healthiest interval. Sometimes if it happens too frequently, you get extinction and you get a loss of chaparral completely. But this is a slope where you have a healthy regrowth after chamise burns up on Walker Ridge. Lots and lots of plant diversity that comes. Here's the remnants of the chaparral shrubs, and here's a whole new crop of herbs that are producing seeds. Seeds will be dropped and they'll be ready for the next big fire, hopefully in quite a few years from this one. Well, another important plant community usually in areas where the soil is a little bit heavier than in chaparral. Chaparral are on the soils that have the greatest penetration, are oak woodlands, dominated by a variety of species of oaks, like blue oak, for example. And as you go from these open areas into oak forest, sometimes it can be really dense and provide a great habitat for a huge amount of wildlife. But you have the same pattern of high diversity of vegetation at a local level. You get these herbaceous areas on certain kinds of soils, on certain exposures to sunlight, and then oak woodland here, especially on north slopes, would get a little less sun. And once again, you have a very diverse landscape with lots of species and lots of kinds of vegetation and lots of variety of scenery. Well, a special kind of oak woodland are our valley oak woodlands. And unlike the blue oak woodlands, these are typically on the floors of valleys. And they typically are have a very shallow water table. And their water table comes oftentimes from moisture that moves horizontally from the great rivers like the Sacramento River in the Central Valley. Moves horizontally to provide a rich understory and a similar kind of lifestyle as the deciduous forests in the eastern United States, because they get plenty of water, so they're kind of protected from the Mediterranean climate. They're deciduous oaks that get more water than most things do in California in the middle of the growing season. But because they have plenty of shallow water, porous soils, they were the most ideal places for the early farmers to start their croplands. And as a result, these valley oak forests are some of the most endangered plant communities here in California. Only a few remnants can still be found, like this one, which is protected down at the Casumnes Preserve. Well, when people first entered California and entered the Central Valley, they found something that was unlike anything they'd ever seen before. Fields of flowers that went on for miles, solid colors of flowers. Wouldn't be horses there then. Oftentimes they just had to walk across these fields. In landscapes that looked a lot like this. Hills off in the distance, but miles and miles of flowers. Very few grasses. And actually though, if you see these areas classified, they're all classified as grasslands, which is really kind of unfair because the original species that were here, the diverse natives, are not grasses for the most part. There are these many, many herbs, a huge amount of diversity here, lots and lots of species. But because we've had so many weeds, including weedy grasses, come in, they've not only diminished the value of the name, but they've also tended to crowd out all these natives. So as you can see, these areas were massive, at least on years with normal rainfall, masses of flowers that incredibly impressed the first people that wrote about them. They'd never seen anything like it because really nothing like it exists on Earth. That's why I like to go back to the original name, call these California prairies, which doesn't favor the weedy grasses, but talks about all these native herbs that are here of many, many species. And this occurs even in the flora of the San Joaquin Valley. These are medias in Kern County in the little bit of the San Joaquin Valley that's not intensively farmed. Here's something similar further north. This is in Bear Valley, and this is an area that Tuleyome takes wildflower tours each April. And there's a lot of diversity in Bear Valley. Here's a completely different yellow field. The other one was pure white. Lots of diversity in Bear Valley. And it's one of the few places where it hasn't been completely taken over by weeds. Very well managed landscape. Along the floor of the Central Valley, those were annuals. They weren't all annuals. We have perennials as well, like narrow-leaved mule ears. This is on the middle of the Central Valley. There's always talk about how along the roadsides there were bunch grasses, but actually this is a plant that shows up along lots of roadsides in the Central Valley. An important part of these California prairies are vernal pools, areas where water ponds, and they have their own distinctive flora and fauna as well, because they have a lot of endemic little crustaceans like fairy shrimp, but many, many species that only grow in these vernal pools as the water gradually evaporates from these low spots as the water warms after the winter rains. One of these vernal pools that's actually right at the edge of the tidal marshes is this one down in Solano County, which has Contra Costa Goldfields, a plant that's essentially extinct in the county it's named after, but does survive in a few places in Solano County. And just beyond are the tidal marshes that are an important part of California's biodiversity. They have animals like that are endemic, like the salt marsh harvest mouse. They have birds like Ridgway's rail. It's not entirely endemic here because there are subspecies further south, but one of the best populations are in the tidal marshes of the estuary here beyond this picture. Well, there are native grasses in the Central Valley. The most important one is actually this creeping wild rye, Lamus triticioides, or now Elamus triticioides. So it can be dominate floodplains with riparian forest here in the background, but it can also grow up hillsides. And one of the reasons you don't see more of it on hillsides is cows love it. And if there's grazing, they pretty much cause it to disappear. But as a lot of hillsides around the Bay Area no longer have cattle grazing, it's coming back just on its own, not with restoration, to dominate hill slopes in a lot of the smaller ranges around San Francisco, Oakland, and Berkeley. Well, riparian areas are really important, and this is the exception to the Mediterranean climate because these are fed from melting snows oftentimes or springs. They're not subject to the Mediterranean climate. They have plenty of water available just at the time when days are longest and it's warmest. So a lot of deciduous plants here, like the forests in the eastern part of the United States, a lot of diversity, and very, very important for wildlife. A little less extreme diversity, but a lot of plants and animals only here. And also animals like mink and beaver and otter find this a wonderful home. We have big rivers with big deciduous trees that, like the Sacramento, for example. And when that melting ice backed the ocean up to the Montezuma Hills, it formed a dam to create the delta. And the delta, even though it's mostly farm now, is a home for real endemics. For example, that was the original home of the tricolored blackbird, which is almost a California endemic, and the giant garter snake, which is definitely a California endemic. The only true pure California endemic bird, at least, is the yellow-billed magpie. And the yellow-billed magpie was particularly associated with those valley oak forests that were near the delta and near the riparian zones, but spread out across the valley floor wherever water was shallow. Well, we don't just get those spring annuals, we get a whole new crop of plants in a group that called the tar plants that is extremely diverse here in California, many species, and covers the landscape in a good year. Sometimes they're called tar weeds, but they're much too pretty, I think, to be called weeds, covering these slopes. It's interesting that it's a group of plants that are herbs here in California, but very different looking herbs over in Hawaii because they're close relatives of the silver swords that grow on top of the volcanoes on Maui and Hawaii. And on those great open spaces, California prairie, Tuleyome are coming back and providing the control of the weeds that they once did. They became very rare, they almost went extinct, but now they're coming back and doing quite well. Another one that's not doing so well in the Central Valley because it needs the flat valley floors is the burrowing owl. And it needs areas where there's only very, very short vegetation so it can see predators. And when that's lacking, they're disappearing. We've lost an awful lot of our burrowing owls, and they don't do well except on the valley floors. Well, one thing that is common from coast to coast, mostly in Canada, is what's called taiga. These are conifer forests of firs and spruces that extend all the way from the Atlantic to the Pacific in a big belt. These conifer forests have many, many unique animals and plants. But they extend south into California as conifer forests through the Modoc Plateau and the Cascades Range where Burney Falls is located, all the way south to those sky islands like the San Bernardino Mountains, the San Gabriel Mountains, and the Peninsula Range. So you can see them in the Northern Sierra, which gets the most snowfall, but the forests tend to be rich as you go south because as they get taller, they can take more rainfall and snowfall out of the westerlies. So they're rich around Lake Tahoe, although if you go over to the Nevada side, you can see the effects of the rain shadow because the forests are much more water stressed on the Nevada side than they are on the California side. And there are mountain meadows here, which have many, many unique species, very high diversity, and there are openings in the conifer forests that are extremely important for our plant diversity here in California. Lots of big trees in these coniferous forests, big trunks. And we mentioned how soils and geology are places to store that winter precipitation. It's also stored in the trunks of these big trees. So our Mediterranean climate here in California has some of the biggest trees. Actually, it does have the biggest trees in the world, and they're adapted to storing that winter precipitation so it can be used during the warm season. Here we go down to Yosemite Valley, where the mountains were carved by those great glaciers that when they melted, they caused the sea to rise to the point where it filled San Francisco Bay and filled the Delta. But even up here in the coniferous forests, there are deciduous riparian forests that are important for a lot of the wildlife. Our tallest trees in the world are actually the redwoods along the North Coast Range and extending into a few places where rain is heavy in the South Coast Range, like the Santa Lucia and the Santa Cruz Mountains, where rain is high. And these trees are so large that they form an ecosystem at the top. Well, most of the voles in the world are pretty terrestrial, but there's a species called the Sonoma tree vole that actually lives in the treetops of our redwood forests. And there's also a bird that nests in the treetops, the marbled murrelet, where all of its relatives nest on sea cliffs. But you notice this is pretty far inland where this was taken. You notice there's not a lot of epiphytes on the trees. There's not a lot of fog here. There's a kind of a myth that redwoods need fog, but what they actually need is a lot of rain. They're limited to mild temperatures and rainfall of at least a normal 40 inches a year, but they do just fine with no fog at all, even when temperatures can be pretty high in the summertime. They do get close to the fog belt, but the real trees of the fog belt, and only in the fog belt, are these big grand firs, Sitka spruces, or Sitka spruce, only in the fog belt around Fort Bragg. And it's these fog belt trees that have this classic covering with epiphytes that people up in, when they see pictures of the Olympic rainforest, associate with rainforest, but they're actually characteristic of fog forests. They're the same phenomena that you get in cloud forests in the tropics, only here our cloud forests are fog forests along the immediate coast. The most characteristic of the fog forest trees, one that extends the entire length of the fog forest along the immediate coast, is the California myrtle, the California roseberry myrtle. And here's a small forest right along the ocean just beyond this ridge. Another characteristic of the fog belt are our pines and our cypresses, like the ones at Monterey Peninsula and Point Lobos. These are trees that are only barely hanging on here in California in the foggiest, coolest places. But you take them over to New Zealand in a different climate, and they grow like Douglas firs, and they're the center of a huge lumber industry. They're much more adapted to the climate in New Zealand than they are here in California. Here in California, they're barely hanging on in our foggiest coastal sites. Well, this cold current is also very rich in fish. We get an awful lot of seabirds that take advantage of this, like murres, cormorants. And we get animals like our California sea otter. And we also get plants like our daisies along the sea cliffs as well. Well, you remember we get quite a bit of desert that comes into California, and deserts with cacti. But that desert is really rich in Arizona, lots of cactus species. We get saguaro cactus all over Arizona, but they barely make it across the Colorado River into California at all. And those diverse cacti in Arizona are associated with monsoon rains. We don't get those in the California deserts. So we get some cacti, but not nearly as much. But we do get wonderful wildflower displays when there's a good rain on the desert. And then up in the moist springs, we get palm groves too, like this one. But not a lot of cacti in the hills. By the way, that monsoon that comes up through Arizona actually reaches the southeastern part of the Sierra Nevada and provides a lot more summer moisture than almost anywhere else in California. And as a result, it's the only place in California where we get native birch trees, except for some very moist areas up in the Klamath Mountains. And from those deserts, we get plants that extend into the very dry parts of the southern Central Valley. And the southern Central Valley is actually drier than the western part of the what's called the Mojave Desert, because the San Emigdio range is a basically stops the rainfall that comes into the southern part of the San Joaquin Valley. So you get desert plants here on a good year, like this desert candle. Get kit foxes that come in from the desert into the San Joaquin Valley. And another desert group are the spadefoots, which are mostly in dry areas. Although I mentioned that we had the highest number of endemic amphibians, those amphibians are actually mostly, excuse me, in the North Coast forest where it's really, really wet. So that's where we get a lot of amphibian diversity. Well, we get a little bit of cold desert up in the northeastern part of California along the Nevada border. And this also adds to California's biodiversity, because we get things like sage grouse coming into California in this kind of habitat. This is an area that's the headwaters of the Feather River up here in the mountains. But this sagebrush also has another species, the dwarf rabbit, which is only found in the sagebrush and is unrelated to our other rabbits. It's not related to the jackrabbits particularly. It's not related to the two common species of cottontails we have. It's only found in this cold desert here, and as a result, it does get into California. This is our California native fillory. It's become a very rare plant, even though we have a lot of non-native fillories that are some of our commonest weeds. This native fillory, because of competition from weeds, has become very rare. And preserving this was one of the things that got Tuleyome interested in the North Coast Range and managing the North Coast Range for its biodiversity, that ultimately led to Tuleyome initiating the Berryessa Snow Mountain National Monument campaign, which became successful and created that wonderful national monument. And another conservation victory of Tuleyome, with a lot of its stakeholders like the City of Woodland and a number of other groups, is Woodland Regional Park, just at the eastern edge of Woodland here. It was set aside for extremely rare plants that in most cases have been destroyed by the intensive cultivation on the floor of the Central Valley, like Pomage birdsbeak here, which thrives in Woodland Regional Park, and alkali milkvetch, another rare plant that's protected at Woodland Regional Park. And the tar plants here, two different species, indicate how good the native vegetation is doing at Woodland Regional Park. This is solid native vegetation here. Then in the background is Riparian Forest, which is a very actively used as a nesting place for hawks. We had a red-tailed hawk fledged some healthy young not that long ago from this Riparian Forest. So if you look at California, it's really an incredibly beautiful place. Not only is it a biological hotspot, but it's that hotspot biodiversity is reflected in incredible beauty, like these California poppies that are at the edge of the Berryessa Snow Mountain National Monument, and hill slopes like this. Well, here's something that a fellow named Bob Gibbons that went all over the world looking for the most beautiful places to see wildflowers. And this is the photo he used to introduce his book, The Best Places to See Wildflowers in the World, the 50 Best Places. So this was his lead in. Well, I've actually found this hill, and it does show up just like this. It's still there, just like Bob Gibbons photographed it, but it's completely unprotected. No protection at all for it. So we could lose it at any time without more conservation. And as the population grows, we not only are the most biodiverse state, we also have the highest population. So our natural communities are always at threat. And we need to have an aggressive conservation program for the great biodiversity that we have here in California. If you want to read more about biodiversity, not only in California and how it compares with the rest of the United States, biodiversity throughout the United States, still the best book is a book called Precious Heritage, produced by the Nature Conservancy and other groups. Still a wonderful book. It's one that I learned an awful lot about biodiversity from. I highly recommend it. Okay, well, that's the end, and maybe we can, if we have some.
Okay, great. Thank you, Glenn. Oh, somehow you went on mute. Are you still there? I mean,
Yeah.
say something, see if I can hear you.
Say something.
Okay, this is
All right, good.
any questions or texts or?
Well, let me go through the chat first. There are a couple of questions. Early on, there's a question about where are the pronghorns? So where are the pronghorn in California?
Oh, the pronghorns,
Northeast, right?
pronghorns have been introduced a number of places there. They've been introduced where their original habitat was in that sagebrush desert in the northeastern part of California, but they've also been introduced in open areas, prairie areas in the southern Coast Range, and that photograph was actually in the southern Coast Range near Carrizo Plain.
Wow.
So they almost became extinct in California, but they're being brought back and are doing very well now.
And Sammy mentioned that she saw pronghorn in Sierra Valley this spring. So
Sure. Well, Sierra Valley is one of those areas that is a great spot for the sagebrush plains that is the most classic habitat for pronghorns.
okay, another question. During your talk, you were using the term herb as opposed to forb. What is there a reason for that, and what's the difference?
The difference is anything that is not woody is an herb, but a forb is an herb that's not a grass. So it would be, or actually there's some other related families that are usually not considered forbs, like sedges and rushes. They're usually not considered forbs either. But it's mostly the broadleaf plants in all the other families that are the forbs. And they're the ones that the earliest explorers of the open areas of California found so dominant, but they've been kind of squeezed out of obvious existence by so many non-native grasses, and yet they're still there. And you can find most of the diversity, just not in the great numbers. And in a good year, in the right spot, they'll come back with these beautiful displays of forbs that I showed some of the photos from.
I have a question about the tar plants, and
Yeah.
it seems like they're pretty unappreciated. And one reason is that they bloom later, right?
What's that?
Don't they bloom later?
They do. They bloom later, and they were actually called tar weeds, and there was all this interest in reviving the bunch grass that was supposedly falsely the dominant in the Central Valley. There's no real evidence that it ever was important. It's more important up in the foothills, and yet we had these tar plants dominant in the Central Valley, and they weren't appreciated. They were treated actually in the weeds of California as something people wanted to get rid of, and yet they were they were dominating many parts of the Central Valley. As a second crop, you have a spring crop of forbs, and then this is the fall crop of forbs.
Okay, there's a question if you could share the location of that hill that Gibbons used his picture.
It's at the edge of Carrizo Plains National Monument, but it's not part of Carrizo Plains National Monument. A great goal would be to extend the monument just a mile or so and take in that hill, because it's pretty amazing.
Okay, did Native American burning practices promote biodiversity in California?
Well, biodiversity was not measured, but it was here when the first botanists got here, so presumably it did. Certainly, I remember my first introduction to the importance of how important fire can be was up on the Palos Verdes Peninsula, which formerly was one of the Channel Islands, and it was connected to the mainland by sediment coming out of the San Gabriel Mountains. But it was pretty much dominated by vacant lot of non-native grasses. But I saw one vacant lot that was burned, and it was covered by Mariposa lilies, different species of the one we showed, and it was pretty clearly the Mariposa lilies germinated from their bulbs because of that fire. So fire can be really important if it's not too frequent in promoting biodiversity, but we have too many fires and they're too hot, it can do some damage as well.
Okay, for the areas that were not overtaken by invasive weeds and grasses, what was the management that helped prevent or slow the invasive species?
Actually, surprisingly enough, it was what people called overgrazing. Very heavier grazing than was typical on California rangelands. And as a result of the heavy grazing that created bare spaces among the non-native grasses, there were places for the natives like the California native fillory to come up and survive. So actually, sometimes what we think of as grazing that's too heavy is actually good for natives.
So I have a grazing question too. You mentioned that the one native grass that's coming back in the Bay Area, I forget the species. It's the one that was climbing up hills.
Alamus or Lamus triticoides, creeping wild rye.
Okay, and you said that cows love to eat it.
Cows
So
to pretty much disappear wherever they were. And but when cows are removed, it came back and it's become the dominant in a lot of places in the Berkeley Hills, for example.
So I guess my question is, before cows, they were native grazers like elk and deer and pronghorn.
Cows actually replaced the Tule elk, which had a very similar ecological role to what cattle do today, and in areas that where they're being brought back as part of the original fauna of California prairies. They're doing the same thing that cattle do in the sense of making spaces in the non-natives for natives to come back.
Okay, question, where can we see the native fillory?
Good question. It would have to be in a Tuleyome sponsored tour. It's one that you need to walk to. We haven't had any tours up there for the general public, but it's something that we might be able to do in the future.
Okay, those are all the questions in the chat. If anybody wants to turn on their mic and their video, if they want to just join a discussion, if you have any questions for Glen, you're welcome to. Everybody's shy.
Great. I'd be glad to talk to all you folks. Good to see all these names. Some familiar, some not so familiar. I'd love to have the opportunity to talk to you. And I think Bill indicates we have the time to do a little of that.
Yeah, if any of you have not been on Glen's wildflower tour, please join us in the spring. It's really spectacular.
Looks like we've got a hand raised from Rick.
Okay, Rick.
Okay, with the move away or the push to move away from fossil fuels and so many solar panels and farms, so-called farms going up, and wind turbines, how do you balance our diversity and possible damage to our biodiversity with solar and wind turbines?
Well, that's a very good question, because there are areas that were some of our best prairie areas that are now covered with these solar panels that actually, for the amount of land that they use, don't produce a particularly intense energy. In fact, there was once a study that if all of California, if every acre of California was covered with solar panels, the loss to the world's biodiversity would be a much greater percentage than the gain of solar power, because our biodiversity is so high. So we have to be very careful about this. One of the things that Tuleyome is sponsoring is a proposal to get more solar panels on rooftops where they're not competing with our native vegetation. And because you're right, native vegetation is very sensitive and can be rapidly destroyed by some of these huge projects. And we've seen examples both in the desert and in the southern Coast Range.
Thank you.
And of course, wind turbines are something else too. They are harmful to a lot of birds like raptors, and they're also very harmful to bats. We do have very effective spots where there's an awful lot of wind that moves through a limited area, like in the Montezuma Hills. Those are the kind of places to put them, but there are some examples of people that want to put them there just to say they created a wind turbine that really don't have that much wind and aren't producing that much energy, and yet they're doing equivalent amount of damage to the flying animals.
Thanks, Glenn.
You're welcome.
Okay, anybody else? Not seeing anything?
Well, if there's no more questions, enjoyed sharing some of the things I've learned with all of you. And the important thing, I think, is we've got a wonderful amount of beauty, diversity, plants, animals right here at our doorstep. And it's just a challenge to make sure it survives. We're doing all we can here in Tuleyome, and I hope you appreciate what Tuleyome is doing in this area, and continue to help us do that. Thanks.
Thank you very much, Glenn. Okay, see you guys next month. Bye.